Okay, good morning, everyone. Thank you for joining us. Today we're going on to episode number 17. We're going to be covering commercial rainwater harvesting. We're joined by Shawn Crawford, which is the National Sales Manager at Rainwater Management Solutions out of Virginia. He's very active in ARCSA, the American Rainwater Harvesting Association, where he's been working on different projects, more on the commercial side. This is, of course, part of the series that we've been going through. We are now at number 17 and counting. We have up to about 26 that are booked so far, so thank you for all of you for joining us. One of the reasons why I picked rainwater harvesting, I know it's kind of an interesting one. We're not going into technology and we're not going into contaminants, but it's something in between. And I don't want to say it's emerging because, of course, rainwater harvesting has been around since, Romans. But it's just the way we look at it and the way things are designed. And everybody thinks of rainwater harvesting as a rain barrel, something that you might be using to water your garden with some excess water that's coming off of your roof. But what we've seen, it's really grown from there, which I think that are going out there now that we're taking a look at more of, anything this size, or you're going into something like the Tampa International Airport. We also have, there's also a lot of projects out there in Texas where water scarcity is not just, we can potentially do rainwater harvesting. It's something that where there's a real need for it. Clear example is in California. There's some fire suppression in there, and thank you, Lily, for this image. But some of going on in California where they're storing water during these massive rainstorms, where they can actually have it and use it in the future. So quick little background on AWC, if this is the first time you're joining us. AWC, we've been around for a little over 40 years. We design and manufacture water treatment plants worldwide. We are a Canadian-based company out of Vancouver, British Columbia. We typically separate everything between potable water, wastewater treatment, and then, of course, some of these skid-mounted systems. What makes it very unique as we tie into something like rainwater harvesting is we wouldn't typically be using something like dissolved air flotation for rainwater. However, we are doing some kind of treatment, especially if it's going to be stored for an extensive period of time. So you would touch on something like a reverse osmosis, ultrafiltration, and of course UV disinfection as far as disinfection. Shawn, we've looked at a couple projects in California where they were looking for 6 log reduction coming off of stormwater and rainwater. And for those of you that are familiar with disinfection and log reduction, of course, California is very strict as far as the log reduction, especially in a water reuse application. And that's when you would be using rainwater with something along these lines. So with that, we're going to go into the commercial rainwater harvesting portion of this. And Shawn, go ahead, take it away.
All righty. Here we go. All right, so you should be seeing my screen now. Is everybody seeing my screen?
Yeah, that's right.
All right.
We're good.
So commercial rainwater harvesting. So I guess, again, it's Shawn Crawford, Rainwater Management Solutions. Alex, thanks for having me. I have known Alex now for 5-6 years now, and he's been a huge asset for us. When he asked me to do this, I said, absolutely. I've already watched a couple of these seminars. They've been extremely helpful. Today, I'm not going to dig in a lot to the weeds for commercial rainwater harvesting. I'm really just going to look at the overall, just kind of lay out what the industry looks like and what typically goes into a system for us for commercial side. The reason is, again, we only have 15 minutes. So I just wanted to give you a quick kind of synopsis on the commercial side and get into the details a little bit. For Rainwater Management Solutions, just a little bit about us. We've been in the industry for a long time. The company started with my dad in his garage, which is kind of funny when I tell people that. We were building barrels just like Alex showed in his on his slides there in the garage, and then we were wrapping them with wood. They looked really nice, and this was back in probably like 1999, 1998. Well, then for bigger and bigger systems. Now it's evolved to what you kind of see today. There are rainwater harvesting systems out there on different buildings that have been around for long periods of time, but the technology is advancing. And so that's kind of what we pride ourselves on at RMS, is kind of be an industry leading supplier, integrator, professional service firm. And we specialize in rainwater reuse, stormwater reuse, and gray water management. So I'll define what those are here in a little bit. We're headquartered in Roanoke, Virginia. For those of you who don't kind of know Virginia very well, it's kind of in the mountains. Virginia looks like a boot. We're kind of towards the toe of the boot. It's called Southwest Virginia, really. Yeah, we've started here and grown here. So we're members of the USGBC. We're members of ASPE and ARCSA as well. So we try to be involved a lot with different organizations to help promote rainwater harvesting. Below is some of our clientele. We've been, like I said, been doing it for a long time. So when we developed in the commercial side, a lot of people identified us as an industry leader. These companies below are the ones that we kind of work with. And the U.S. government's another one we do a lot of work for. You'd be surprised how many of our systems are on top secret facilities. They're on embassies, overseas, and they're using the rainwater for all sorts of applications that we didn't even think would be possible. All right, so just real quick, rainwater harvesting. What do we classify as rainwater? Because a lot of people think that, oh, rainwater is everything that we're just trying to capture off of an impervious surface. Well, in our industry and how we refer to it at our company is it's a natural precipitation that has contact with a rooftop surface or other man-made above ground surface has not been put into beneficial use. So we would basically calculate or say rainwater is more of just rooftop collection and try to keep it that way. And then we would throw stormwater as something as just an impervious surface like a parking lot or a walking space that we collect from. And the reason is because of the different contaminants that are coming down. And then you have gray water. We're not going to get into gray water today for what we do, but it just includes wastewater from bathtubs, showers, lavatories, clothes, washers, and laundry tubs. We've seen rainwater systems called gray water systems, and so that's why it's definitely important to define those different sources of water right off the get-go with whoever we're working with. So the industry as a whole is for standards and codes is really scattered, and Alex can attest to that. The two big standards we go by as a company that promotes and supplies commercial rainwater harvesting systems is ARCSA ASPE 63. That's a great standard. If any of you all need access to that, you can always ask Alex for that. He of course can supply that. I'm happy to supply it. Another new standard that's coming out is called ARCSA ANSI ASPE 78, and that's focused on stormwater, which will be a little bit different. It's more of the impervious surface, parking lots. How do you deal with oil contaminants and different things like that that are going to be going into the storage tank? So real quick, just to define, the standards are just a way of how we're following things and what we promote. However, codes, when you go to Universal Plumbing Code and the International Plumbing Code, there's some inconsistencies there between the standards. So for example, the Universal Plumbing Code has some different items that they address for when you're reusing rainwater into the building. And it's different for International Plumbing Code for when you're reusing rainwater into the building. So purification for rainwater going into the building, when you're trying to purify it going back in the building, it's different per different codes. A lot of out west they use Uniform Plumbing Code. I've got that misspelled, so it should be Uniform Plumbing Code. And then over on the East Coast, we're using International Plumbing Code, but it's kind of just scattered here in the States. The state, then it goes down to the state plumbing code. So the state plumbing code could completely just say, you know what, I don't like what's in the International Plumbing Code. We're going to do our own thing. And then, not to confuse you even more, we have a local municipal code. The local municipal code has the final say. So let's say that us here at RMS are designing a system with an engineer, and we said, okay, we want to put UV treatment on this system. Well, great, that matches the Universal Plumbing Code or the Uniform Plumbing Code. All right, well, the state plumbing code says you also need to put chlorine on it. Okay, well, we'll disinfect it with chlorine and do UV as well. Well, then you get down to that local municipal code, and they're going to say, well, we want dye injection as well. We want to make sure we're dyeing this water. But you don't need chlorine or UV light. So we follow that code. So it's very scattered for us. And the whole point I'm getting at, there's a lot of confusion at multiple levels. So there's two organizations here. CANARM is the Canadian Association of Rainwater Management, which Alex was a part of, I think still is, and came in, and that's where we met. And ARCSA is the American Rainwater Catchment System Association. What they're trying to do is promote a consistent code and standard on all levels, so we know what we're supposed to supply. It's really just kind of a cluster is what I'll say for right now for what we're trying to figure out. But what I will show is kind of our standard system and what we've gone with based on our experience. So what are the big drivers for rainwater harvesting? Why is there more? One of the big ones, and probably know, but if you don't know, it's really just a certification for basically better standards for sustainability and green building. You get a lot of points for water conservation. Right here, you see all the different points you can get. It's a huge, huge benefit to add some sort of rainwater collection and reuse to a LEED building. It's how you get to different platinum and bronze and all these different scales that you want to go to. The next one is living building challenges. These are really interesting. These are net zero water, so they're trying to make sure that they're not relying on the city water at all. And so this is where you can get into some different stipulations with the city and what the customer wants. They also, for living building challenges, I'd say they're definitely more strict in what they source. So they make sure they really keep track of where the material is coming from, which makes it really interesting for rainwater harvesting components. A lot of, or I'd say, 10% of our products come from Germany because they have really carved out a market there and developed that market a long time ago. Regulatory is another huge driver, and I tell you, that is really driving our business right now. Stormwater runoff, our rainwater runoff, the volume reduction. As these cities grow, there is more impervious surface and more water running off. So we really need to control that, manage that water, and reuse and repurpose that water. So what we're seeing is different cities or municipalities start to promote rainwater harvesting more and more in the States. And you're also seeing it in Canada in different parts. So these are the main applications for rainwater harvesting. There's plenty of other ones, don't get me wrong. I mean, I'm always at a surprise when I hear new ones and get new ones. But the big one is outdoor for irrigation. That's probably, I would say, the biggest one. We see that a lot. Pool, pond filling, building washing, vehicle washing. Then we got indoor for non-potable uses. And the reason we section that out is because we treat the water differently for the different applications. Obviously, as you go from left to right here on this page, the more strict we have to be, or I guess the more purification required to do that type of reuse. So once we go to indoor non-potable reuse, we're talking filtration, disinfection. You can use the water for toilet flushing, laundry washing. Cooling tower is probably the most common one we've seen. Fire suppressions is not bad. That's picking up out west in California a lot, in Washington for obvious reasons, in Oregon. Toilet flushing and cooling tower are probably the main ones on here. The next one is indoor. So on a commercial level, indoor potable use for rainwater is very hard to do. It's a unicorn is how I would describe it. We have done one system that just passed in the state of Virginia, and it's the only system that we know about in Virginia that has gotten approved through the Virginia Department of Health for drinking water. And so they're using it for everything inside of it, and it's in an airport. So they just had no access to water. So all they had was well water, and the well water was very hard, had arsenic in it. It just had a lot of issues, so they had to go to rainwater. Good thing is it's near DC. It's in Northern Virginia. There was a lot of, political influence involved in this. Former Governor Warner for our state was involved, and a few other delegates were involved, and a few other senators were involved to get that going, because the Department of Health was really just had never seen it and really hesitant to look at it. So now when we look at use, the big thing that drives our systems, our sizing, the rainwater harvesting system. So we look at rainfall per inches, roof area, which is, we do square foot, square meters, whatever you want to do. And then we multiply that by a coefficient. And that tells us the potential gallons you can collect from the surface. So for example, 1 inch of rainfall on a 1,000 square foot roof yields about 620 gallons of collected rainwater. That's a lot of water. When you look at that, you think, wow, I could be saving that much water. Well, let's look at it annually. Let's look at it with the size and my usage. So the big thing that we juggle when we size a commercial system is water demand versus tank size. We look at the demand and then the supply. Well, the supply is irregular. We don't know. I mean, people have tried to make a living out of predicting the weather, but we still are not 100% accurate. So what we do is try to get our best assessment on what we think the rainfall for that area will be. And then we kind of come up with an average usage, and we figure out what size tank would you need. Well, what that does, it saves you money. It saves effort, design time. For example, if you look over here on the right, if you're only going to yield 80% of your demand is going to be met by rainwater with a 3,000 gallon tank, does it make sense to go all the way up to a 10,000 gallon tank when you're going to gain maybe 17% more? Is it worth that extra 17%? Because the cost of a 10,000 gallon tank and a 3,000 gallon tank, it's a huge difference. And that goes into our next thing for tanks, because tanks are what people think about for rainwater harvesting. There's a lot of different varieties out there. You've got underground storage, which is on the top left, that's fiberglass. Polyethylene underground storage is what you see in the middle. On the far right, you see metal tanks, for example. Those are the silo-looking tanks that are erected. Will go up, and then those just look great. Those are really good-looking tanks, and they have this little liner inside. On the bottom left, this was done down at an agricultural facility. These are basically crated tanks that are assembled on site and covered with a liner. You've got wooden tanks down there. They're pretty much assembled on site, and then these bands go across. They look great. And then on the bottom right, you have a network of what that is called, that's ADS pipe. It's just high density polyethylene pipe. ADS is the manufacturer of those. There's a lot of other manufacturers that make pipe like that. And that's a series of storage. The big thing that we promote in all the rainwater industry is pre-filter the water before it goes into storage. Let the water calmly enter the tank. Have a floating intake for the water, and then have an overflow for that rainwater system, because rainwater is unpredictable. So we pre-filter the water, step one, to get any big contaminants out. Don't let it store in the tank. Calm the water when it enters in. You don't want to it's like stepping into a lake and you just shoot sediment everywhere. And then take the water from a clean surface. And then overflow is critical. It's good to let a tank overflow. It's healthy because water's coming in and out. So point of use for treatment, this is where we kind of dig down and say, okay, what do we commonly use for commercial applications for water? This is a package system from our group. This is what we do standard. We can make these all day long, but different municipalities are going to change what we can use on the skid. We use commonly a self-cleaning backwash filter, cartridge bag housing filter, carbon filter to eliminate any odor, discoloration, UV light for disinfection. And then we'll have a domestic backup tie-in or flow meter that's tracking what we're flowing for rainwater or whatever backup water that's going to be going into the system to help. Differential fouling in the bag filter, they need to be changed. Typically for water quality, people will say that water can be acidic for rainwater. We find that it's acidic at first coming in at about 6.2 is what we see on average. When it goes out post-filtration, we're usually looking at about 6.5 or 7. Now, total coliform, we rarely see that. The water's pretty clear. Total dissolved solids, it's typically 0 after post-filtration. So just to give you guys some examples, Microsoft is redoing, I can't really divulge too much information on this because they're doing about 25 different buildings on their campus out in Seattle. And so this is one project we've been working on. This is a custom fiberglass tank they wanted being delivered to the site. It's a standard package system. We pump water up from the storage tank through filtration. We store it in a buffer tank, and then we repressurize that water back to the building. They're striving to be off-grid there for the Microsoft campus. They're trying to save millions and millions of gallons. Another one, UC Berkeley Haas School of Business out there. So just they put the rainwater cistern tank right and the manway right in the entrance to the building. So they're very proud of it that they're using it. They're reusing it for toilet flushing. Another good one is Allianz Field. They wanted to use ozonation for this one. This was one of those where they wanted to have so much irrigation use that it made sense to do rainwater harvesting right away. They were collecting from rooftop and parking surfaces. The filtration equipment you see down there to the right is going to be placed in a vault because it's very cold where it's located. And so they wanted to make sure that they could keep it going year round. And then last but not least is a Seagate. So again, I talked about cooling towers. Well, data centers use a lot of water because they have to keep the data, the storage devices cool. So what they'll do is collect rainwater and reuse that for keeping the data centers cool. So that's another one. We reduced the rainwater impact on the job site as well, which was another benefit there. So I kind of ran through that real quick, but that's my information below. If you guys ever want some just information on rainwater harvesting, you can see that down there below too. So yeah.
Thank you, Shawn. Yes,
Exactly.
like you said, there's a lot of information to try to pack it into a 15, 20 minutes. The idea here is to show that on the commercial rainwater harvesting side, kind of break the mold of thinking of rain barrels and trying to take a look at the industry as a whole. On the water treatment side, there's always a lot of opportunities on how you're going to tackle these. We're going to go ahead. We're right at the 20-minute mark. Look at that, right on time. We're going to open the floor up for some questions. If anybody has some questions. Oh, I see Thomas has already put his hand up here with some questions. So what we can do is if you want to turn your camera on, you can. If you want to just punch some questions into the chat box, you're welcome to do so. So go ahead, Thomas.
Hi, thanks. I was just wondering if you're using the rainwater for potable service, does that mean that all your catchment area, like the roof area, has to be NSF materials?
It depends on the municipality. So far, no. No, they did not have to be NSF approved. For the Virginia Department of Health, for that example, it didn't have to be, because then at that point it was kind of where does it stop, right? Because then you've got this roof that's NSF approved, which would be hard to source, and then you've got this conveyance pipe, and then this tank, and then that makes sure that no birds go on the roof. Nothing uses the bathroom on the roof. It's NSF approved. So it kind of I've seen that before, and that's a really good question. But it really depends on the municipality. And then once the municipality brings that up, us as the manufacturer kind of say, well, where does it stop? Because a roof, you can't protect it from getting fecal matter on it or certain things on it if it's collecting rainwater.
I would guess you'd certainly need to be careful of materials, like you wouldn't want asphalt shingle or something that would contaminate the water.
Good. Yeah, absolutely. So that's a good point. Asphalt shingle has petroleum byproduct in it. So yeah, when we do a residential system, for example, we say no asphalt shingle roofs. Stick to metal, clay tile, or there's some few other ones that work really well. So yeah, good point.
And just a quick comment, I noticed on one of your slides you said the total dissolved solids in the collection is 100, less than 100, and after filtration was less than 10, but I think you probably mean total suspended solids.
Sure. We look at total dissolved solids actually, but yeah, total suspended solids. I was meaning total dissolved solids.
Okay.
Yeah,
Thanks.
total suspended solids would typically be removed with a 5 micron or 1 micron filter. So I don't know that we'd be too concerned with the TSS or turbidity. It's total dissolved solids where you would actually see, rainwater is very soft, which is why it's got the acidic portion of it too. So if anybody else has any questions, you can go ahead and put it in the chat box. I have one here to warm things up. So my question was on, you had mentioned that we were using this for fire suppression as well. So you have a very large, you've got sometimes 5,000 or 10,000 gallons of water that are stored there for an extended period of time. So is there any kind of recirculation or anything that you might recommend to keep that water clean?
Yeah, absolutely. So we do recommend recirculation. A lot of that goes to when I showed you that tank sizing chart, not to oversize the system as well, because it's healthy to have water come in and then overflow out. So sometimes in the scenario, we know that the water is not going to be used for a long time. We'll recommend recirculation to help keep that water moving, keep that water healthy. And sometimes we'll do recommend aeration as well. So yeah, it's a good question. But that's typically if we know that the water is going to be sitting in for a long period of time, and a long period of time would be more than 15 days and not being used at all.
Okay. Tom, I don't know if you raised your hand again or if it just
Yeah.
stays there. Oh, go ahead.
Yeah, I did. Thanks. I was just wondering in your graphic of the overflow, it shows it as a top overflow, but I'm wondering if it'd be worthwhile doing a bottom overflow, so you take, sort of the worst quality sediment water for the overflow.
Yeah, and there's been discussion about that too. That's a really good point. Well, we found that we siphon a lot. We look at it kind of like a pond skimmer. And so what we've noticed for rainwater is pollen, like heavy pollen season, it will float on top, and that's organics. So we would kind of want to get that out. So by doing that P trap on top and that beveled top that you see at that overflow, it siphons water out on the top surface. But there's been discussion of doing what you just brought up, which is doing something low and getting particulate out that way. Or any just particulate floating around in there out that way. But what we found by using that overflow device is when it siphons that top surface, it's really effective.
Okay, thanks.
Okay, thank you. Well, if anybody else has any questions, you're welcome. I noticed that the chat box, for whatever reason, was on mute, so I don't know if any of the questions were coming through. If you don't, if you have any more questions, we can end it here, and you can stick around and you can ask Shawn or I some questions. I want to thank everybody for coming. 20 minutes of your time is great. Thank you, Shawn, for everything. Stay tuned for next week. We're going to be going over tube settlers. We're going to have Ryan Harvey is going to be going over some tube settlers and lamella clarifiers. I can never just spit that word out. And some of the design, some of the flow rates, and some of the applications. If you have missed any of our past webinars, shameful plug, they're all listed on our YouTube channel. Please have a look. Please subscribe. You'll see it in there, and you can take a look at some of our past ones. So with that, if anybody wants to stick around, I'm going to finish this off. So thank you very much for coming, and I'll see you next week.